This little video is going to instruct you in what scientific notation is and how to convert it back and forth between decimal notation. We actually start way back with something nice like 2.36 times 10. Now, if you do this kind of slowly, you can have 0, 0, 0, 0, 0, and then you 1, and you'll get a 2, 3, 6, 0, but the decimal place is going to be in that thing. And you learn very quickly that there's a shortcut with timesing by 10 is that you move the decimal place. So that's the first key here. So 5.8 times 10, you're just going to move the decimal place 158. Now so there's the first key, is that timesing by 10 moves the decimal place. Now if we do this, let's do something else. 6.38 times 100 this time with two zeros in here. Well, this one you're going to times by, you're going to get 0, 0, 0, 0, 0, 0, and then a 638. When you move the decimal place all over the place, it's right there at the end. So you're going to move it 1, 2 place. Notice that we're going to move the decimal the number of times we have a 0 here. So let's back up just a little bit and make sure we understand what's going on with tens. Number one, if you take 10 and take it to the second power, that's 10 times 10 is 100. Then 10 to the third power is 10 times 10 is 100, times 10 more gives you 1,000. 10 to the fourth power would be timesing that guy by 10, and so you get 10,000. And you'll notice this really nice, great connection between the exponent on the 10 and the number of zeros you place here. You'll notice this connection here is the number of zeros and the number of times that the decimal moved to get to where it needs to go. So we could have rewritten this one as, let's put this right down here, 6.38 times 10 to the second power, and this number tells us, hey, this decimal gets moved 2 places because we're timesing by 10, so we get 638. If we do that with 6.38 and we times it by 10 to the fifth power, we've got to move it now 1, 2, 638, but then we've got to move it 1, 2, 3, 4, 5. We've got 3 more zeros, and there we go. This number and this number, 6.38 times 10 to the fifth, are the same exact thing. One of them's just kind of shortened up a little bit. Let's give you a bigger example so you can see how that works. If I have 2.4 times 10 to the, say, 15th power, that is the exact same thing as 2.4, but then moving the decimal 15 places. 2, 4, that's one place. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, that's a big number. These very large numbers are used in scientific computation quite often. And so this right here is what is known as scientific notation. There we go. And this is decimal notation. So all you have to do in moving scientific notation to decimal notation is move the decimal that many places. There we have it. Let's do one out here. 3.7 times 10 to the 11th power. Well, you just take and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's it. The decimal is right there, and you've moved it 11 places. So scientific notation and decimal. So if you have a number like 5730000000000, there we go. That's a big number, isn't it? And we wanted to convert it to scientific notation. Notice that there are a lot of different options. You could make it 57300000000 times 10. Or if you moved it, say, 3 places here, you could get 573000000 times 10 to the third. Do you see how if we times this back by added 3 zeros, we get the old number back? Official scientific notation says we have to move it to right here. Even though there are a billion different ways to rewrite it, official scientific notation moves it so there's one number on the left of the decimal. so that the number we first write, like that one, is between 1 and 10. You'll notice like what we did up here. That's not the number 24 or 0.24. So this guy, we would have to move it, and let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be 5.73 times 10 to the 11. Even though there are a whole bunch of different ways of writing it with these exponents here, this is official scientific notation. The question often gets asked, what if we did this with a negative number? Put a negative number right there. Negative 11. What would happen there? Well, let's look at it. And we get, well, negative exponents. Negative goes in the other direction, and that's exactly right. We would actually be dividing by 10 11 times, so we would move it that way 11 places. So we'd have to move it past the 3 and 10 more places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros and the 3 and the 7. So these are incredibly small numbers, and you just move it the other direction. And that should be a summary for scientific notation.